Temperature?
Volume.
You already know. It's a constant volume, constant temperature.
It's a constant volume.
Okay, if it is a constant volume, we know we're talking about that formula.
Okay.
And then I use that formula to find my answer. But what is the problem here? Temperature needs to be in what?
Kelvin.
Kelvin.
Okay, so here, this one between fluorine and carbon, that's a polar bond.
Okay.
But this one is not.
It's not.
Non-polar. So I put yes for polar bonds because there's one.
Yes.
But is it a polar molecule?
Now we go to the other table.
This one?
Yes.
Okay.
So it's not symmetric. Do you have any atom associated with it? Central, lone pair associated with a central atom?
No.
But do we have a polar bond?
Yes.
So the molecule is what?
Polar.
Yes.
Okay. Man, I wish this chart was on the test.
I don't know. Maybe it is. He may hurry and ask.
Yeah, I might, because you know how I'm gonna come Friday to tutoring, and then I was gonna go to the test right away. I think Friday in class is like a study time, so I think I'm gonna take it after class.
Yeah.
So I can ask her like which charts are on the test.
Uh-huh.
So I can be like mentally prepared for it. But we'll see. What would RB2O be? Idiom.
Ruby, let me look your periodic table.
What's this one?
It's here, right? RB. So if you have a RB in the first period, we know this is a +1. And chlorine is a -1. So if you cross charge,
Oh, I did it wrong. I thought chlorine was. Oh, I did oxygen. That's why. Thanks. I read it right and then I wrote it wrong.
So this one. Bond angle of 180.
So I'm crossing here. So this is, is this right where I'm at right now? It's got 298 for their Kelvin.
okay. So now when you cross,
Do I have that even set up right? Is that
so this is your
P1?
P1.
Would be 2,
okay,
and then T1 would be
that,
the amount given, which is
and then your no, yes,
2. So when I cross here, how would I rewrite that? Is that 2T2?
2T2,
Okay. Equals, and then I just cross multiply those?
yes.
Okay.
So how do I do this?
Oh, the empirical formula is,
What I was just doing.
yes, just crossing the charts. So for this first one, you're going to have Cr2 parenthesis SCO4 3.
Okay, so I just changed it.
Yeah.
If this one is symmetric, right?
It's a polar bond, but now it's a polar molecule.
It is a polar molecule?
What do you think?
I don't know. Let's see. Is it symmetric? Yes. Is it symmetric?
It is symmetric.
Okay.
If you put a mirror image in the center of the carbon, you see oxygen in both sides. So
Okay.
it is symmetric,
So since it's symmetric, it's not
non-polar.
Okay.
Good.
So I got this wrong. It's saying that the answer is 2, well, let me make sure I'm on there, yeah. 2.5.
What did you get it?
Oh, so I've got to convert this back to
Celsius.
Celsius. Okay.
Well, let me check. Let me do the, can I use your calculator really quick? 298 times 3.5.
Okay, so I actually did that one wrong. I think I put 2.5.
Yeah,
So I did this one right.
perfect.
So how do I figure out what the name is without having to use Google?
Okay, so this is the thing. Every time you have a transition metal, go back in the periodic table. And we call transition metals this guy's here. Every time we have a transition metal, you need to tell the oxidation number from it. So go back. So why did you say chromium? It's chromium 3 because it is a 3 plus. So instead of 2, you say 3.
Are you sure?
Yeah.
Because it says 2 here.
But 2 is just for, we need 2 chromiums to stabilize it, plus and minus charge.
Okay.
But chromium 3 is telling the oxidation number. So you say the name of the metal. What is this one here called?
Iron 2.
Iron 2. And then we say the polyatomic with ATE at the end.
So iron
2